And the clock has hit 7 a.m. here on the East Coast. I'm Jim. Welcome to your Thursday morning cup of cyber. Time to get up and at 'em. It is Thursday, so it's a 3 for Thursday. Today we'll be talking about 3 topics that relate to what we're talking about this week. Today it's DHCP, NAT, and the DMZ. So join us after the short intro. Find out why today is Popeyes' favorite day. Good Thursday morning. It's March 26th. We are coming live to you from Cyber-Recon's fake server room. And today it is the 26th of March. That happens to be National Spinach Day. Of course, would be Popeye's most favorite day. We're still heading down the Security Plus track. So if you're with us, still rolling with Security Plus, talking about network devices, network protection, network technologies, all of the good stuff that goes along with that. So we dig in. We're talking this week about network devices and network security. Touching today on a couple quick topics, 3 quick topics. The first one is DHCP, or Dynamic Host Configuration Protocol, right? So each computer, as we've been talking this week, each computer has an address that is changeable. The IP address, or Internet Protocol. Each computer also has a MAC address that should not be changed. So we're going to talk today about that changeable address and how it can be changed. So when we set up a network, we can assign these IP addresses manually. So system administrators can go in and manually assign IP addresses. And we'll talk today about Internet Protocol version 4, not 6. But no, that 6 is out there. We'll talk about 6 later. We're talking strictly about Internet Protocol version 4, or IPv4, as we say. So we can go in and we can assign these IP addresses manually. And you've probably seen them. So an IP address is 4 octets, right? So you can have a set of numbers, a dot, a set of numbers, a dot, a set of numbers, making up 4 octets. So you see them like 192.168.1.1 is one of the addresses you've probably seen before if you've ever looked at IP addressing. It's a private address. It's one of the most common you'll probably ever see. So those 4 octets have to be set uniquely for each computer in your network so that traffic knows where to be routed at layer 3. And obviously, if you have not checked out the OSI model, I'll throw a link up there after the live recording, and you can go look at the OSI model video, and we'll talk about those different layers. But layer 3, we need an IP address to be routed. So it would take a lot of time for a network administrator to go in and set IP addresses for 100 or 1,000 or 10,000 computers, right? So don't get me wrong, it's been done before in the past, and some folks prefer what's called static IP addressing, where you manually go in and set an IP address for each individual computer. DHCP is a little different. This is a system that's built in to a lot of home routers, what we call small office, home office routers, which live inside access points. In big environments, it's going to be a server on its own, or it may be part of your Active Directory environment, right? So this system automatically assigns IP addresses to computers as they join the network. So when you join the network, you query for a DHCP server, you request an address, and one is sent to you. So it's within the range that's set by the administrator. And the administrator will set a time that reservation lives in the server, right? So your computer will be assigned an IP address, and you may keep that IP address for a very, very long time, maybe years. As long as you keep logging into the network, you'll probably be served that same IP address over and over again. because there's a reservation table. So we can either manually, as administrator, we can manually go in and say, I want this MAC address to always get this IP address, or we can set the timeout where once a system is assigned an IP address, it will always get that IP address as long as the DHCP server sees that computer within a specified period of time, a couple days, a week, whatever we want to set. This definitely reduces the amount of time it takes to administer the network tasks for a network, right? So if you thought about, say it takes 30 seconds to go in and set an IP address for a system. If you have 10,000 or a million systems, that could take considerable time, and to keep on top of that. So DHCP servers keep track of this stuff. They keep track of what IP address has been assigned to what MAC address. They do a lot of other administrative tasks in the background, but know that DHCP is the system that dynamically assigns IP addresses to computers on a network. So the next topic in our 3 for Thursday is network address translation. So now that your system has an IP address, you've hit the DHCP server, you've been served and assigned an IP address, and normally it's going to be in one of those ranges. And towards the end of the lesson today, we'll talk about private IP address ranges. And most people in most environments will work with private IP address ranges inside your local area networks. These private addresses just mean they can't be routed across the internet. They can only be used in your networks, your home networks, your office networks. When they hit the internet, they won't be routable. They can only be routed in local area networks, in your networks that you work with, right? So if I have an IP address on my computer that can't be routed across the network, across the internet, how can I get my traffic across the internet? Well, that's where network address translation jumps in, right? So if we have an IP address that can't be routed, or we don't want routed across the internet, then we're going to change that. We're going to use a system called network address translation, and we're going to change that IP address on all of your packets going out to the internet, right? So normally when it hits the router at the edge of your network, and again, in small office, home offices, we'll see this done in that router that lives in an access point, or maybe it's a dedicated device, dedicated firewall, or dedicated border router, or something like that. When your private address, and we'll use the 192.168.1.13, maybe that's the IP address of the computer we're talking about. When that IP address, when that packet hits that last device before it goes out across the internet, when we do the network address translation, we take that 192.168.1.13 and we change it into the router's publicly addressable IP address. And then the packet can be sent off across the internet, and it will be routed, right? Sometimes we know this as masquerading the IP address. Sometimes it's called masquerading the IP address. It hides the network behind that border device. So it's on a firewall or whatever the border device is. We can hide it. So we could have 1,000 private IP addresses using that same single publicly addressable IP address on the router or the firewall. It helps in a way by obfuscating the IP addresses you're using inside. And really, if you're using NAT, you could really use any IP addresses you want. And it's better to stay with those private addresses just in case someone makes a misconfiguration and doesn't go through your border device and somehow connects to the internet directly. I would say still stay with private addressing on the inside just in case something bad happens, right? So you may ask that if we have 1,000 devices connecting to this single device and getting that device's IP address across the internet, how does the device keep track of it. And one of the ways we can do this is using port address translation, or PAT. And really what PAT does is it takes each of those IP addresses when that packet hits that NAT device, normally that border router or that firewall, the device will take and append a port number to the end of the IP address. And we have thousands of port numbers now we can use. So we can take our example, 192.168.1.13, and maybe we're going to add port 5000 to the end of it. So now all my packets going out through that device will be tagged with that port number. So now all my traffic is going to be identified as 192.168.1.13:5000. And then I know that traffic as the NAT device, I know where to send that traffic back to when I do the translation on the return path. So this helps keep track of all the different connections in the NAT device. We can also, like we talked about earlier in DHCP, we can assign static NAT, which doesn't seem to make sense, but we can do this. We can say 192.168.1.13 is always going to be mapped to this port number. So it's going to be the NAT device's public address, but it's going to be mapped to a specific port number as well all the time. So it'll always be mapped that way. So we can keep track of it in case we've got maybe security on a device that ensures that we always have the same identifier for that machine. So we can do that. We can have static NAT. We can use a one-to-one relationship between a specific computer and a specific address. And it allows a device inside the network to use a private address and be directly translated into the same thing every single time, right? And it's important because sometimes, if we think about it, there are devices that will have multiple external MAC addresses, right? So if you have a border device that maybe has 4 or 8 or 100 connections to the internet, each of those will have a unique IP address. So with one-to-one mapping or static mapping, we can not only map it to a specific port, but also to one of those specific external IP addresses. So important to know. The most important thing to know about this, the most, critical thing to remember about NAT is it takes an internal address that's normally private and converts it to an external address that can be routed across the internet. It allows us to use a number of internal addresses that are normally in a private range and map all of those over to a single publicly routed IP address. And obviously we say single. If we have multiple network cards, we on that device, we map to all of those network cards. So just know it's a translation of the address, right? So talking about private IP4 ranges, right? These are private ranges on the slide over there. Man, I always got that backwards. These are the 3 that you'll normally see with inside LAN networks, local area networks. If you're using a small office, home office router, you will see pretty much exclusively these addresses being used by default from the DHCP server within that access point or that DHCP server inside your device, right? And we have 3 we can use, and we're not restricted on what we use. It's not, no one is monitoring which one you use inside your network to tell you're using the wrong one. So you can use whichever one you want. It doesn't matter. The one you'll see most often, in my experience, is a Class C address. And this is the one that most home routers, small office routers, home office routers, access points use 192.168 something, right? So those last 2 octets you see are in red in our slide here. So those last 2 octets can go from 0.0 all the way up to 255.255. So you can have one LAN or local area network that is 192.168.1.1 1 through 254, 255. If you want to use that, I would say no. And then when we fill that up, we use all those up, then we go to 192.168.2.1 through 254. So you can see if we keep doing that, we keep rolling that, we keep incrementing. And if we think about it like the numbering system, the decimal system, so every time that rightmost octet, that placeholder in the rightmost position, every time that gets to 255, we have to roll it back over to 0 and then add something to the next octet over to the left. So when we get to 192.168.1.255, then we have to go to 2, the next range. But by doing that, you see you can have over 65,000 addresses in a Class C range. So for most small office, home office, that's way more than you're ever going to need. So that's why we see 192.168 used so much in small office, home office devices. That's not the only one that can be used. We can use Class B ranges, which is 172.16.0.0 to 172.31.255.255. And again, following that same process, we can see this range will give us over 1 million addresses. So for a bigger organization, we can use Class B addresses on our internal networks. Again, these are private. They won't be routed across the internet. And then if we're a large organization, we can use a Class A address space, which is 10.0.0 to 10.255.255.255. And again, if you do the math on that, over 16 million addresses are available in that. So we have plenty of space for private IP addressing. So it's important to know it's important to know that private IP ranges can't be routed across the internet. So we're going to have to do something like translation at our border device to make sure that all our computers can communicate over the network. And then we know there's 3 classes, A, B, and C. We'll talk about more about these classes later, but it's important to know in the private ranges, these are the address spaces you use. If you have 10 computers at home, sure, you can use Class A. There's nothing wrong with that. It's not going to hurt anything. So it's important to know the ranges of private addressing. You'll probably see these all over and over and over again. So I have seen a Class A address on some of the small office equipment I've seen. And you definitely will see Class A and Class B on enterprise level stuff. So our last topic on our 3 for Thursday is DMZ, right? And that's not that show that comes on every day. That's like TMZ, right? We're not talking TMZ, we're talking DMZ. This is a term, the Demilitarized Zone, and obviously it comes from the military. And it's an area where we set up those devices that belong to us, but those devices that also need to connect, sometimes directly to the internet and be connected to by individuals of the internet, right? There's certain devices you have in your environment, like maybe your web server. Maybe you have a web server. You wouldn't want your web server on your internal network, because then people from the internet would have to get on your local network to connect to your web server, right? So mail servers are the same thing. To get and send and receive, mostly to receive mail, you're going to have a machine that people can send directly to, which is a mail server, or your DNS or domain name service device, if you have one of those. These are devices that have to be reached by the internet, devices on the internet, but you don't want them on your internal network, right? So a lot of times we'll set up what's called a 3-leg perimeter firewall, or 3-leg network, or a 3-zone network, right? And that's what's kind of displayed in the diagram over yonder. So we see the internet, and we know the internet is full of all kinds of bad stuff, right? So we throw a firewall up, which is the red block there, and the firewall is going to make some routing determinations, right? The green network we see yonder is our internal network. That's what we trust more than anything. We normally call that the trusted zone. a lot of organizations, we're going to a theory of zero trust, but it is the most trusted zone we've got. So that's our internal network. That's where we have our databases. That's where we have our workstations. That's where all of our processing goes on. That's our secure network, the most secure. So we've got the internet on one side of the firewall. We've got our internal LAN on the other side of the firewall, but we need a place for things like DNS and mail and web servers and anything else that we want the internet user to be able to reach into and connect to. So that's why we have this third leg, this yellow network, which is on the bottom, and that's the DMZ. It's protected, but it's not protected to the same level as our green network, our internal network. It's set up with hosts that can be reached from the internet, and maybe that's through port translation or all kinds of port forwarding or different things. But we're going to protect it to some level, but we can't protect it to the same level as the internal network, just because some things from the internet have to be able to connect to it. So we set up this DMZ, and the DMZ is more tightly managed than the internet connection, but it's less secure than our internal space, right? So it's important to know that that's the point of a DMZ, right? And then the last thing, I know we're rolling through this morning, it's probably the fastest morning yet this week, are intranets and extranets. Intranets, this is that green zone, right? There's a local or restricted communication network. It's where we do all our internal communications. This is where we can have our business sensitive information can be in here. This is where we normally have our workstations and our normal connection set up. An extranet, it's not like the internet, but it's a network we share with our partners, right? So we can connect to an extranet, and maybe it's all our suppliers and all our distribution centers and stuff like that are not part of our company, but we want to be a little more secure than the internet. But they're not as secure as our local area network. So it's an area that can be partially accessed by authorized outsiders. So think about our suppliers. We want our suppliers to be able to send us reports. Maybe we have systems that our suppliers are using to send us information, but we don't want that going directly into our green zone, our internal network. So we have an extranet. It's important so the companies can share data using all the features and benefits of the internet while being more secure than the organization. Keeping that data secure within the organization, select organization, specific users. So it's another area, kind of like that third leg of our firewall, but it's another area where we have an extranet, an external network that we connect to use with our partners and other folks. So that is the rundown today for your Thursday morning Cup of Cyber. 3 for Thursday, covered 3 topics. Hopefully they all ring true for you. DHCP, Network Address Translation, or NAT, and the Demilitarized Zone, or DMZ. Let me know, what are your thoughts on these 3 topics? Anything in there that doesn't make sense? Anything in there that you're like, wow, I understood it differently before? Or anything that, any stories, comments you want to share? Throw them in the comment section below. I do see we got 2 visitors with us this morning. Glad to see people up at 7 a.m. East Coast time. I know it's early, especially as we start moving to the west, early and earlier. So please hit the bell to be notified every time we go live, every time we throw new content out. Like and subscribe. It really helps us. And just daggone it, be safe out there. It's a crazy world right now. So glad you're up. Glad you're learning about security. If you're going to go take the Security Plus exam or one of the other security exams, let me know in the comments what you know about these different exams, what you think about them. And that all being said, I will see you tomorrow morning.